Hello.
Good morning, sir.
Good afternoon, everyone.
Sorry, sir. Good afternoon.
Hello, madam. చెప్పండి. చెప్పండి. తెలియదు మేడం, ఐడియా లేదు అసలు. సార్ హెచ్ఓడి సార్ చెప్పండి మేడం. నాకైతే ఐడియా లేదు. ఇప్పుడు నేను నా క్లాస్ అయితే ఆన్ అయింది. ప్రాబ్లం అంటే షెడ్యూల్ అవ్వలేదంటే యూ హ్యావ్ టు ఎంటర్ టాపిక్ అండ్ టైటిల్. ఓకే 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 అవునా, అయితే ఈ రోజు అయితే ప్రాబ్లం అయింది. ఓకే ఓకే ఐడియా లేదు. యా ఓకే. గుడ్ ఆఫ్టర్నూన్. గుడ్ ఆఫ్టర్నూన్. We'll start the session. Okay. So let me share the screen. So just now I forwarded previous class PPT, so which is on calculating pre-stressing losses for creep, shrinkage, and relaxation of steel. Right. So today we are going to start a new module, module 3. Yeah. So I welcome you all for 21st lecture on pre-stressed concrete structures. So let me first share you the contents which were there in the third module. So third module is divided into two segments. One is analysis and design of prestressed concrete structures towards FLEXURE, and analysis and design of prestressed concrete structures towards shear. Okay. So before starting any design, so first we have to analyze the structure towards its strength. Okay. Strength in point FLEXURE, right? So in the point shear. So because we all know when a member is subjected to load, so first member tends to shear. So if the member is safe towards shear, then it will try to resist towards bending. Okay. So by that, load, shear, and FLEXURE is the pattern of analysis of any structure or any behavior of any structural element. Okay. So in that point of view, so we are going to study two elements. One is FLEXURE and shear in the designing of prestressed concrete elements. Okay. So coming to FLEXURAL part, so here we are going to discuss a few points in FLEXURE. One is analysis of sections for FLEXURE. Okay. So sections in the sense, one second guys, one second. So analysis of sections for FLEXURE in the sense, pre-stressing elements so will be available in different sections. So there will be a rectangular section, square sections, I sections, because if you go for bridges, your sections will be in the form of an I shape. Okay, there will be symmetrical I sections, there will be unsymmetrical I sections, and there will be circular sections, hollow circular sections. So like that, we will first try to know how you can able to analyze the different sections towards FLEXURE. FLEXURE is nothing but bending. Okay, and next, so the beams which are going to be pre-stressed in different patterns. Okay, how you can able to pre-stress your structural elements. So you can do strike pre-stressing, you can do concentric pre-stressing, you can do eccentrical pre-stressing. Okay, bend and parabolic tendons. So these are the pre-stressing ways. So where you can do pre-stressing members either in the form of a pre-tensioning or post-tension, right? And along with that, you will try to know about the stress diagrams Okay, so I think you all know. Let us take a rectangular section, right? So what is the stress diagram of a rectangular sections towards bending? Can anyone? So let us take a rectangular section like this. Okay, rectangular section. So this is your neutral axis. So if I try to draw the pure bending, I mean a bending stress of this particular rectangular section. So rectangular section. So your stress diagram will be like this, isn't it? So where in the neutral axis, your stress will be zero. I mean your bending stress will be zero. Maximum will be below the neutral axis and above the neutral axis at a distance of y by 2 distance, right? So in that way, your member is going to have a stress diagram. So this is called a bending stress diagram, okay, or flexural stress diagram. So in this way, so we are going to draw the stress diagrams of the pre-stressing elements like pre-tension and post-tension elements. Okay. So here we are going to treat member in the form of an elastic mode. So here the elastic designing of simple pre-stressing glass slabs, beams, and different kind of sections like rectangular sections, I sections, right? And what is the way of cable profiling towards bending, and what is the layout of the cable? Cable in the sense the profiling cable. So we call it as a sheeting cable, right? Cable profiling, right? And what is the cable layout? So these are the topics which are going to discuss in the lecture, right? So next, in the second part of the third module, so we are going to discuss on shear. So here, particularly shear, in the sense we are going to discuss about general considerations of shear towards pre-stressing elements, and what is the principal tension and compression, and how we can able to improve the shear resistance of concrete. I mean, pre-stressed concrete by horizontal and vertical pre-stressing methods, okay, or by using inclined or parabolic cables. So why? Because any structural element, it should have a resistance towards bending and shear. Then only the member will be safe under shear strength and flexural strength. Okay. So in that way, how to improve the shear resistance of the concrete. Okay. So that we will able to study in terms of pre-stressing elements over here. And the next one is what are the analysis of rectangular and I-beams towards shear. So let me draw for the same rectangular section. What is the shear stress diagram? So let us take a rectangular section like this. Okay, so this is the neutral axis. If you draw the shear stress diagram, your shear stress diagram is this. So at neutral axis, your shear stress will be maximum. At uppermost fiber and the lowermost fiber, your shear stress is zero. Okay, so this is the stress diagram of a rectangular beam towards a shear. In the same way, here also we are going to analyze the rectangular and different I sections for shear, and we are going to design the shear reinforcement as per IS code provisions. Okay, in terms of 1342. So these are the topics we are going to cover in the third module. So now let me share you pre-stressed concrete notes, so where you can able to go through the content for the exam. So let me share you the screen of the notes. So let me first show you from starting. So this is the lecture notes on pre-stressed concrete structures. So which was prepared for you guys. Okay, so it was prepared by me. So where you are going to have all units notes over here. Okay, in the first unit, you are going to have a definition of pre-stressing, basic concept of pre-stressing, and what are the terminologies going to be used. I will share these notes to you guys after completion of the class. So here the terminology in the sense, what do you mean tendon, or what do you mean cable, what do you mean anchorage, okay? And what is the pre-tension definition, what do you mean post. And coming to the materials of pre-stressing concrete members, so what are the materials going to be used over there, like cement, you know, concrete, steel in terms of pre-stressing steel, okay? And what are the major considerations towards, like in terms of durability, in terms of fire resistance, and in terms of cover requirements for pre-stressing concrete members, okay, as per 2001. Sorry guys, because 1980 is outdated. Okay, and what is the necessity of using high-grade steel for pre-stressing members, right? And what is the history and the development of pre-stress of the pre-stressed concrete structures, right? That is also there in the first unit. Completely theoretical. I think we all discussed about these examples in the first presentation. So where we are discussing on introduction of pre-stressing structure, right? Okay, and the other example is the pre-tensioning the spokes in a bicycle wheel, isn't it? So like this, and what are the different forms of pre-stressing steel? So your steel will be available in different dias of strands, having the wounded with the different plies. So this is the 3-ply strand. This is a 7-ply strand. Okay, 7-ply strand with a different dia of each ply. So like this, your strands will be available. Okay, and what is the nature of concrete steel interface, and the stages of loading also was clearly given. And coming to the advantage of pre-stressing, so advantages in terms of drag, in terms of durability, in terms of serviceability, right? And how better it can be used for uncracked service roads, how it can able to accommodate for long spans with more depth, okay, and suitable for precasting construction, and what are the limitations of pre-stressing, okay, and what are the different types of pre-stressing. Everything was covered in the notes. Okay, you can just go through this for the exam point of, right? Okay, and next, coming to the second part, um, just let me just scroll down, right, because you can be able to go through the notes in your free time. Okay, and a few problems on pre-stressing members also. You can just have a look and you can solve them. And the next one is losses of pre-stressing, which we discussed in the second unit. Okay, so I think in the second unit there will be different methods of pre-stressing, like Prestressed method, um, Gaylord method. All these methods were there in the presentations also. You can just go through them. And these are the losses of pre-stressing, so which we discussed about all 6 losses. 3 are like immediate, and 3 are time-dependent losses, right? Okay, okay. Note was given very clearly, and for every loss there will be a problem given. Okay, so you can just go through. I think the same problem which we discussed in presentation, which was produced in notes. Okay, so these are notes on losses of pre-stress, right? So coming to the third unit. So third unit here, as I told you, we are going to discuss about the analysis of structural members and pre-stressing structural members under FLEXURE, right? So here we are going to discuss about the members which are under axial load. So why? Because beams usually subjected to axial load. Axial load in the sense the load passes through the center of gravity of the section, and we are going to analyze those members under FLEXURE, which is going to refer with the evaluation of the problem. So in this analysis, what we are going to know exactly about, what we are going to evaluate. Okay, so I given 4 points over here. So we are going to evaluate in pre-stressing concrete elements under permissible pre-stressing, so which is going to be based on the allowable stress. So while transferring load from sand to concrete, right? And the second one, we are going to do the stresses, calculation of stresses under service loads. What do you mean service loads? Service loads is nothing but working loads. Okay, working loads are nothing but allowable loads. So these are compared with allowable stresses which are under service conditions. Okay, this is also we are going to evaluate in analysis of members under FLEXURE. And the next one is ultimate strength. So what actually what extent you can able to apply load on pre-stressing strands to make your concrete hammer, to make your concrete squeeze. Okay, so where your concrete will undergo hammering. Okay, we will undergo hogging. So that ultimate strength also you are going to calculate over here. So this is going to be compared with the demand and the factored load. Okay. And the next one is the entire load versus deformation behavior. That is also very important. Why? Because usually in RCC member, when the member is subjected to load, it will deform, and there you can see the profile of beginning. But in pre-stressing members, the deformation won't be towards downward direction. Deformation will be towards upward direction when you stress the member. Okay, when member is subjected to load, when the member is under service condition, obviously your member will become straight instead of bending. Okay, understood. So this is what the analysis at the transfer and service loads are going to be presented in this particular unit or particular module. And here the evaluation of the load versus deformation behavior is required in special type of analysis. So why? Because we are analyzing those particular members, it will take you know much time. So that's the reason why. So we are going to have the load versus deformation behavior in terms of graphs. So through that we can able to evaluate it. And coming to the assumptions. So because while you studying the bending stresses in your strength of materials, right? So in your strength of materials, you want to bending stresses and shear stresses, isn't it? So in bending stresses, even while deriving the pure bending equation of like m by a is equal to sigma by y is equal to e by r, there are few assumptions. What are the assumptions? First one is your member obeys Hooke's law, your stress is directly proportional to strain, member is homogeneous and isotropic, member will remain same even before and after loading. Okay, so the cross section of the member won't change before and after loading. So like this, the number of assumptions were made in RCC bending stresses. But here, let's discuss what are the assumptions there for designing of pre-stressed concrete elements under FLEXURE. Okay, so here the assumptions are given like this. So the analysis of members under FLEXURE going to be considered with a few assumptions. What are the first one? Concrete is homogeneous and elastic material. Okay, we all know concrete is brittle, but every material or every member will have some extent of elasticity. Okay, even concrete is also having elastic nature. So by that, that is the reason why concrete is having an Young's modulus. So when a material is having an Young's modulus
Sir,
constant. So by that, those materials will have an elastic property. Okay, that itself says
sir,
that concrete is a homogeneous and elastic material. And next, within the range of working stress, and within the range of that elasticity, working stress and range. So working stress in the sense, member which is under working condition, member is reaching under working loads. Okay, then only you can able to call member as an elastic material. If by having the elasticity nature of concrete, when you stress the stand, your concrete is bending towards upward direction. If the concrete is not having elasticity, will it able to bend upward direction? No, there is no possibility of bending towards upward direction. So it is just because of elasticity nature. Understand? So by that, within the range of working stress, here the both concrete and steel have it behaving elastically. Okay. So being concrete and steel behaving elastically, then only your total compound member is bending towards upward. Okay. So that is the major assumptions over here. Within the range of working stress, both concrete and steel behave elastically and not withstanding the small amount of creep. Why? Because creep is a time dependent one. You can't able to see any kind of creep at the initial stages of the pre-stress or initial stages of the member which is under working loads. Okay. So in that way, creep is a very small amount you can able to see in the initial stages of the structural elements. So where which occurs in both the materials under sustained loading. That is what. So because as creep is a time dependent one, at a constant loading only you can able to see the long-term deflection of the beam, which that deflection is not a elastic deflection. That deflection is a plastic deflection. Okay. So why? Because you can see the permanent deflection in a member due to creep. Okay, that deflection it can't able to regain its original shape and size. Okay. So that is the reason why we are not going to consider any kind of deflection which is happening due to creep. Okay. So in initial stages of the design. That is the reason why in assumptions we are considering creep as very low. Okay. And next one. What is the next assumption? So here the plane section. What do you mean plane section? Let us take a rectangular beam. So in a rectangular beam, if you see a cross section will be the rectangular plane, isn't it? So the plane section before bending is assumed to remain plane even after bending. I think the same assumptions which was made in the bending equation, in pure bending equation, right? So that is what happened. So even bending also, the rectangular section it should not change its cross section. Rectangular section rhombus hypotomy, rectangular section square hypotomy, rectangular section irregular shape hypotomy అనేది ఉండకూడదు. Okay. So by that the plane section before bending is going to be same even after bending. So which implies what it implies? It implies that the linear strain distribution across the depth of the member. Okay. So before bending and after bending your section is plane and minimum. So that says that your linear strain distribution. What do you mean linear strain distribution? So if you see the sorry guys, I can't able to draw it here. So as it is a Word document, so I think you can able to understand what is linear strain distribution. If you see the strain graph of any element, so when it is under elasticity, your graph will be linear, isn't it? So the linear strain distribution across the depth of the member will implies that your member is plane before and after bending. Okay. And the next one is prestressed concrete is one in which that have been introduced the internal stresses of such magnitude and distribution that stresses resulting from given external loading is counterbalanced with desired degree. What do you mean that? What do you mean is, for example, how much pre-stressing force you are going to apply on the member? ఎంత అప్లై చేస్తారు ఎంత అప్లై చేస్తామంటే సో లెట్ us take a raw member B, apply a load. To what load it is bending? So that load is going to be applied in a form of a pre-stressing force to make that downward deflection to upward deflection. Understand? So that is the force required to counteract the deformation of the member, okay, towards upward direction. By that, member will have more load carrying capacity. Why? Because you are making member to hog instead of sagging. Understand? So that is the meaning of pre-stressing concrete. So where it is going to bend in upward direction instead of bending into downward direction. Okay. That is nothing but we are counteracting the load, or counteracting the deformation in chapter. Okay. So why? Because we are distributing the stresses with the same magnitude and with the same deflection. కిందకి ఎంతైతే డిఫ్లెక్ట్ అవుతుందో మనం అప్లై చేసే ఫోర్స్ వల్ల పైకి డిఫ్లెక్ట్ అవుతుంది అనమాట. ఓకే. సో దట్ ఈస్ వాట్ ఎగ్జాక్ట్లీ హ్యాపెనింగ్. దట్ ఈస్ వాట్ assumptions we made in designing the member under FLEXURE. And the next one is plane sections remain plane till failure. That we know that is called a Bernoulli's hypothesis. Okay. So and the next one is perfect bond between concrete and pre-stressing steel for bonded tendons. Why? Because if there is no bond between concrete and steel, what happens? Do you think that load transformation or load transmission will be there from steel to concrete? No. Why? Because you are not going to apply any force on concrete directly. You are going to apply tensile force on strand. That tensile force on strands will make concrete to squeeze. Squeeze line up there, the pipe bend out. Okay. So that means there should be a perfect bond between concrete and steel. When there is no bond, there is no load transmission taking place from steel to concrete. So that is the reason why perfect bond strength between concrete and steel is used a perfect load transmission. So that is very important. Okay. So that is what we are currently taking as an assumption. Okay. So these are very very important. These assumptions are important for your external exam point of view also for writing theoretical. And next, coming to the principles of mechanism. So what are the principles of mechanism? What type of mechanism we are using here to analyze the member under FLEXURE? Okay. So here the analysis which are going to involve three principles of mechanism. Understand? So to analyze your pre-stressing member under FLEXURE, so here we are going to involve with the three principles of mechanism. Mechanism and mechanism in the sense when you apply load, member is bending. That is what a mechanism. So here to analyze the member, what mechanisms we are considering here is one is equilibrium, second one is compatibility, third one is consecutivity. Okay. So consecutive relationship is also one of the principles, compatibility and equilibrium. So I think we all know about the equilibrium. Why? Because in analyzing your determinate or indeterminate elements of structures, so you have used the equilibrium conditions, right? What are the equilibrium conditions? All summation of horizontal forces is equal to 0, all summation of vertical force is equal to 0, all summation of momental force is equal to 0. Those are the equilibrium conditions. Okay. So in the same way, the first principle we are using here to analyze the pre-stressing elements is equilibrium. So here equilibrium in the sense equilibrium of internal forces with the external force. So that is what we are going to consider. So here the first principle is equilibrium of internal forces with external forces. So where the compression in concrete, okay, if you take a rectangular beam, in a rectangular beam, where will be the compression forces will occur? On top of the beam. So where the member is simply supported. Where the tensile stresses will develop? Below the neutral axis. Okay, let us take a simply supported beam. In the simply supported beam, above the neutral axis will be under compression, below the neutral axis will be tension. Okay, when the both compression and tensions are equal, the distribution of forces are equal, then only you can say the member is under equilibrium condition. So that is what the first principle of mechanism, equilibrium of internal forces with the external load, where the concrete in compression in concrete is equal to the tension in the tendon. Understand? And then whatever the force we are applying in stand in terms of tension, the same force it should transform into concrete in a form of a compression. Understand? So that is what an equilibrium statement. అర్థమవుతుందా? మనం కలిసి ఎంత ఫోర్స్ అయితే మనం పుల్ చేస్తున్నామో, the same force it should transform into concrete in a form of a compression. That is what an equilibrium condition. Right? So by that, the couple of concrete and tension are equal to the moment due to external load. So when the both forces are equal, what happens? There will be some couple generated. Okay, couple and the moment. So that is what, when the compression and tensile forces are equal or loads are equal, the moment will generate. So moment due to the external loads will generate, which is equivalent to the moment, right? And the next one is compatibility. What is the compatibility? The compatibility of the strains in concrete and in steel for bond tension. అంటే ఎంత కాంపాక్ట్ గా ఉంది కాంక్రీట్ అండ్ స్టీల్ అనేది. సో హియర్ we are going to discuss in clear. So that is also one of the principles. So here the compatibility of the strains in concrete and in steel for bonded tendons. So where the formulation also involves the first assumption of plane section remaining plane even after bending. So I think so we made this assumption in terms of compatibility. So by analyzing the pre-stressing elements towards structure. So for unbonded tendons, the compatibility is in terms of deformation. అంటే మనకి ప్రతి మెంబర్ అనేది కంపాటబుల్ ఉంటుందని మనం చెప్పలేం. ఓకే, సో కంపాటబిలిటీ విల్ బి దేర్ వేర్ యూ కెన్ ఏబుల్ టు అసెస్ ద మెంబర్ టువర్డ్స్ ఇట్స్ సెక్షన్. బట్ ఫర్ అన్బాండెడ్ టెండాన్స్ ద కంపాటబిలిటీ విల్ బి ఇన్ టర్మ్స్ ఆఫ్ డిఫార్మేషన్ గా ఉంటుంది, రైట్? In the last one is conjugative relationship, which are going to relate to specific strength in materials. As we already discussed many times, where your member is behaving elastically, so all the relations between stresses and strains are directly proportional. Okay, so that is also one of the principles. Why? Because you all telling me, I mean, discussing that member always Hooke's law, your stress is directly proportional to strain, which leads to member is behaving elastically, right? So when we are discussing all these, that itself relates that there is a conjugative relation between the stresses and strains in the materials, right? So these are the principles of mechanisms. So out of which we are going to use the first mechanism, which is an equilibrium mechanism, to analyze the pre-stressing member towards flexion. Okay. So in the next class, we are going to discuss about what are the variation of internal forces and and what are the different modes of pre-stressing, like straight pre-stressing, axial pre-stressing, circular pre-stressing. So these are all we are going to discuss further. So the next topic which covers with the variation of internal forces and how the forces will vary in reinforced concrete and pre-stressed concrete. Okay. So let's discuss this in the next class. Okay. And analysis transfer, how the load transformation takes place from steel to concrete. What is the base concept of that? Everything we are going to discuss there. Okay. Right. So that's it, guys, for today's class. So any doubts you can ask me related to analysis of numbers introduction, limitations, assumptions, and principle of, mechanisms of analyzing pre-stressing elements towards structure, right? So last 9 minutes left. So any discussion? Right? You can respond. Any doubts? Vamshi could join ahead. Guys, any doubts? You can ask me now, or else you can text me also.
Sir,
Mithun, step Mithun.
సార్ ఇందాక మీ వాయిస్ క్లారిటీ లేదు సార్. ఇందాక పిలిచారు సార్ మిమ్మల్ని.
ఏంటంటే Mithun, actually we are sitting together in the room, so I can't speak loudly, so that is the reason. But for the tomorrow's class, I will try to have a mic. Okay.
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 Okay, sir.
So because in this class there are few more people, so by that I couldn't able to speak loudly. Okay.
Okay, sir. Thank
So
you.
that is the reason. But for tomorrow's class, I will try to maintain earphones, so by that your voice will be clear. Guys, any doubts? Guys, anything else? Any doubts? If you have any doubts, you can ask me now, or else we will wind up. Shall I? Shall I close the section? Mithun, fine.
Fine, sir.
Vamshi, Kalpana, Gopi, Karnakar, Naveen, Raju, Srinija, Monica, Anusha, sorry, Anusha. Anyone? Any doubts? No doubts? Right. Okay. So then we'll see you in the next class. Right. So we'll have a few more information towards analysis of structure. I will try to put some more effort on it. Okay.